This tutorial shows you how to find the buried thermodynamic properties for aqueous and MSC models in ESP. Unfortunately, these parameters are not displayed directly to the screen, but they are saved internally in the program. We're going to create a program, or rather a chemistry model here for a very simple system. So you're probably familiar with this, but we're going to create a new process. We're just going to happen to call it thermo. And a chemistry model also calling it thermo. We're going to select the mixed solvent system for this, no private databases, and we're just going to add carbon dioxide, sodium chloride to the system along with some H2S and calcium chloride. And we're just going to go ahead and generate a very quick model. You've seen this before, so there's nothing new here. We're going to go into create a very simple block, just the mix block for our example here. Test. We'll create a feed. We'll just make it very simple, 25 degrees, 1 atmosphere, 100 moles of water. We'll put in a very small amount of carbon dioxide, very small amounts of the gases, and a fair amount of the solids. We'll go ahead and normalize that. We'll just give it the effluent. We'll set it to adiabatic. We're now ready to run it. Here's the part that's new. We're actually going to use something called calcades. Calcades brings up a variety of options. The one we are interested in is trace. So we're going to turn on the trace file. We'll set trace to on. This can create very large files, so we don't always keep it on by default. But right now we'll keep it on, and we'll run it. And the program is ready to run. It runs very quickly in this case. Here's the output, and you'll find that we don't have any of the nice, good activity coefficients that we want here at all. What we need to do now is to locate a specific file called the OUE file. We'll do that next. Okay, we've shut down ESP for this part of the tutorial, and we're now going to look specifically for an output file. What I've done is I've located the folder where my work files are in. In this case, it happens to be in a folder I called OLI course. What I've done is I've sorted the file by date. So I've turned the file so the newest files appear at the top, and the trace file has the extension OUE. So the file we created is the process file, thermo, and the file extension is OUE. This is a text file, and I've associated Notepad with this type of file. So I will open that next, and we can then scroll through the file to see our thermal parameters. Okay, we've opened up the file thermo.oue. Now there's a lot of information in this file, and it's really for diagnostic information. But what we can do is we can very quickly find the streams we're looking for. The first thing that happens in all ESP runs is that we perform an equilibrium calculation on the inlet streams. So here is the inlet stream here. We then will go through and calculate the blocks and populate the output streams. So sometimes we're looking for the word streams, sometimes we're looking for the word block. But in either case, what we can do is we can search for the letters pH, which is a good test. So I'm just going to go into Edit and Find, Control F, and just look for the letters pH and a colon. When I do this, I'll very quickly scroll down to the first part of the summary. This happens to be for the feed, and you can do this for any number of files you're looking for. And here we have some data. So we have the temperature and pressure of the file. This was actually reported to ESP. We have the compositions, and all this information is the same. As we scroll down, though, we're going to find the activities of all the species in solution. Okay, and here they are. We have the activity coefficient on a what we call molal basis. That's column number 1. and on a mole fraction basis, that's column number 2. For example, if I'm looking for the activity coefficient for the chloride ion, it is right here in the OUE file for this temperature, pressure, and conditions. So the activity coefficient on the concentration-based scale is the first one, and the concentration activity on the mole fraction concentration scale is the second one. Additional information are the equilibrium constants for the chemical reactions that take place. Here they are for both the anhydrous and hydrous solids, and so forth. And then the program exits because it's a very simple case. But that's where the activity coefficients are stored in for ESP. Thank you.